And we'll go on to section 2. So what do we now know? The major parts of a centrifugal pump and how the pump itself basically works. In this section, we'll learn more about the external components and what they do. This is the second section of a 4-section module on centrifugal pump principles. This section covers external components. By external components, we mean those parts that can be seen when you walk up to an operating pump. Specifically, we're talking about the casing, the stuffing box, the bearing housing, and the coupling. Casings are usually made of cast iron for low-pressure pumps and of steel for high-pressure pumps. Steel or cast iron casings serve 3 primary purposes. They house the internal parts, keeping them in the proper position and protecting them as well. They confine the fluid being pumped and direct its flow. And finally, they form the volute and connection points for suction and discharge piping. Pump casings have 2 designs, solid or split. Solid construction casings have a removable cover or faceplate that gives you easy access to the impeller. They're called solid because the discharge casing is one piece. Split construction pump casings are either axial or radial. They're axial if the split is along the center line of the shaft. If it is, the upper half of the casing can be removed, giving easy access to the pump shaft, impeller, and bearings. Radial splits are perpendicular to the center line of the shaft. The advantage of this design is that the casing can be made up in segments and bolted together to form one pump. With some larger centrifugal pumps, there's a gland sealing line that supplies sealing fluid to the packing in the stuffing box. Most often, the sealing line delivers fluid to the stuffing box from the upper casing. Sometimes, though, the sealing fluid may come from an external source, particularly if the pump is pumping a corrosive or abrasive substance. There's another difference on larger centrifugal pumps. The external section of the lower casing half may form a small open well to catch fluid leakage. There's a pipe called a slop drain at the bottom of this well. Leakage can be drained through this pipe. Now let's take a look at the stuffing box. It holds the packing gland. That gland, in turn, is designed to regulate fluid leakage around the shaft. We'll talk more about pump packing in the next section. A gland follower is also found with the stuffing box. Basically, it's a bushing designed to hold and compress the packing gland in the stuffing box. Bolts usually hold gland followers in place. They're also used to adjust the gland follower's position. These are bearing housings. They support and protect bearings. There are different types of bearings. We'll look at them and their purposes in the section 3. Right here, next to the bearing housing, are flinger rings, or shields. They're attached to the pump shaft and fling fluid leakage from the packing gland away from the pump shaft. That keeps the fluid from leaking into the bearings. You already know that on most centrifugal pumps, couplings join the shafts of the driver and the pump. They have to be flexible enough to handle misalignments between the shafts, as well as changes in the driver's speed. Alignment of both shafts is critical for good, smooth operation of the pump as a whole. If they're not aligned correctly, the shafts and other pump parts will vibrate. If that vibration gets serious, it can put enough pressure on the shafts and couplings to break them. Vibration can do other damage too. It can cause bearings to wear, internal parts to rub, and impellers to become unbalanced. Now this is just to name a few of the problems. When any of these occur, we've got downtime and equipment that needs to be repaired. In the next section, we'll look at the internal components of centrifugal pumps. Stop the tape now and review this section. View the tape again if you wish, and then move on to the next section when you feel you're ready.